Again, welcome to Pre-Calculus Mathematics 164. This lecture is covered operations with algebraic expressions. Our main objective is to go through a polynomial functions and also to perform arithmetic operations with polynomial functions. So first, what is a polynomial functions? In the general form, it will look like an times x to the power n plus an minus 1 times s to the power n minus 1 plus all the way to a1 times s to the power 1 plus a0. Now, a0 will be a constant value. A0 will be our constant value. Then from an to a1 or a1 to an will be our coefficient of each term. In this case, the term can be x to the power n, s to the power n minus 1. So again, let's see example here. We say 4x cubed minus 2x minus 3. Normally, what we always do in polynomial function is that the x with the highest degree will come first. So here we have an x to the power n, then the next will be an minus 1, s to the power n minus 1. So the example here is 4x cubed minus 2x minus 3. So in this case, 3 will be our constant value, 4 will be the coefficient for s cubed, and 2 will be the coefficient for x. And here we say this is a third degree polynomial in x with a leading coefficient of 3, and also the constant value is negative 3 minus 3. There's a reason why we say a third degree, because the highest exponent is 3. Now, if a term has 2 or more variables, then we say the degree of the term is the sum of the exponent of those variables. In this section, we have only x variables. For example, if you have s and y, then the sum of the highest degree of y and x degree will be the total degree for the equation. So here we say the degree of a constant term is always 0. So the degree of 4x squared y is 2 plus 1, which will give us 3, because x is, the exponent is 2, and y, the exponent is 1. So we had the 2. Here we have 2 variables, s and y, so we had them. Now, the degree of 6xy is 1 plus 1, because s is raised to the power 1, y also is raised to the power 1. So it will be 1 plus 1, which is 2. So here we say the degree of a polynomial containing 1 or more variables is the degree of the term in the polynomial having the highest degree. Therefore, 2xy minus 4x plus c, 6, is a second degree polynomial. Why? Because x is 1, y is 1. So 1 plus 1 will be 2. So it's a second degree polynomial. So a polynomial containing 2 terms is called a binomial. And also a polynomial containing 3 terms is called a trinomial. And a single term polynomial is called monomial. So here 2sy minus 4s plus 6, we have 3 terms here. So this is trinomial. Now let's look at operations with algebraic expressions. As we said, we can do addition, multiplication, division, and also subtraction. So all the 4 arithmetic operations. So our first example here, we have 3x plus 2x. Now, 3x and 2x, they are the same term, so we can add them together. Now, in polynomial addition and subtraction, we can combine the terms. If they have the same unit, they have the same like terms. So, for example, 3x plus 2x, the answer will be 5x. But 3x plus 2y, the answer will be 3x plus 2y, because I cannot combine x and y together. The second example here, 9xy minus 3xy. Again, the terms are the same, xy, xy. So I can subtract 3 from 9. So it will be 9 minus 3xy, which will give us 6xy. The general rule here is that the terms with exactly the same variables, factors, are called the like terms. So when we are doing addition or subtraction of polynomial, the like terms can be combined together. Either if it's addition, we add them together. If it's subtraction, we find the difference. So that's the rule for addition and also subtraction of polynomial functions. the like terms can be combined together. Now, this is a multiplication. In terms of multiplication, here, for example, we have 3 monomials. Why we say monomial? Because it's each term, and it's only one term for each. So in this case, we are going to multiply everything. So 8 times 2 times -3. So we get 8 times 2 times -3. Then next we have x times s cubed times x. Then y cubed times y squared. So we have the 3 terms. Now we already went through the rules of exponent. So 1x means s to the power 1. So it will be 1 plus 3 plus 1. So s will be raised to the power 5. Y is 3, 1, and 2. So y will be raised to the power 6. Then 8 times 2 times -3 will give me -48. Then s to the power 5th and y to the power 6. S to the power 5th because the first s is raised to the power 1, plus 3 is 4, plus the third one is 1, so 5. Now let's see, the second question is division. So division is also the same as multiplication. Now it's only addition and subtraction. We combine the like terms. But in multiplication and division, we either multiply the same terms together or we divide the same terms. So the multiplication here, for example, we multiply 8 and 2 and -3. We multiply x and s cubed and x. We multiply y cubed and y squared. Now the same thing here also. 15, -15, we can divide it by 3. Then we can also divide s squared by x. Then we can divide y cubed by y to the power 5th. Remember, if it's division, if the base are the same, we subtract the exponents. We subtract the denominator exponent from the numerator. So let's go through the steps here. Our answer will be -15 divided by 3, s squared divided by x, y cubed divided by y to the power 5th. So we get -5x 1 over y squared, because 3 is less than 5. So y will come down. So our final answer will be -5x divided by y squared. Now, operations with algebraic expression, always the symbols of grouping are used in algebra in the same way as they are also used in arithmetic of real numbers. So we have removed the parentheses in the process of adding and subtracting polynomials. And other symbols of grouping, such as brackets, are also treated same as parentheses also. Now, when there are 2 or more symbols of grouping involved, then we begin with the innermost parentheses before the outer. So let's see an example here. They say we should multiply 3x plus 4xy plus 3y by 3x minus 2y. So in this case, we can multiply x with 3s, 4sy, and 3y. Then we multiply -2y with 3s, 4sy, plus 3y. Then we combine the two. So we write it in a vertical form. So first we start with the x. S times 3x is 3s squared. S times 4xy will give me 4s squared y. X times 3y will give me 3sy. Everything is positive. S is positive. Now, -2y times 3s will give me -6xy. Then negative times positive is negative again. Now, -2y times plus 4xy will give me -8xy squared. Y is 2, so 1 squared. Then -2 times +3 will give me -6. Y times y will give me y squared. Now we can combine the like terms. Now 3s squared, we have only one 3s squared, so we put it down. Also 4s squared, y is only 1, so we write it down. Then we have plus 3xy minus 6xy. It's like term, so we combine it. So -6 plus 3 will give me -3, then the xy. Then -sy squared is only one term. We leave it. Then minus 6y squared. Y squared is only 110, so we leave it. So that will be our final solution. So again, with the addition and subtraction, we combine the like terms, but with multiplication and division, we multiply or we divide the same terms together. So sometimes we have what we call the special products. For example, here we have s plus a times s plus b. This is the same as writing s squared plus abx plus ab. And we can, again, verify it by multiply each term. So s times s will give me s squared. S times b will give me sb. Then a times s will give me what? Ax. So we get a plus bx. Then a times b will give me ab. Same thing here, ax plus b, cs plus d. We multiply each terms. So ax times cs will give me acs squared. Then as times d will give me axd. Then b times cs will give me bcs. Then b times d will give me bd. So that's what we have here, acx and acs squared plus adx plus bcx plus bd. Now, here we say it's easier to remember these two special products if we note their structure. Now, we can also obtain this product by finding the products of the first terms, then the outside terms, inside terms, and the last term. This is known as FOIL method. Maybe some of us covered this in our algebra, pre-algebra class or intermediate algebra, the FOIL method of multiply two binomials together. So that's what we're going to. Now, the FOIL method is good for binomials. So we multiply s minus 4 times s plus 3. S minus 4 is binomial because we have two terms. So in this case, we multiply the first value. So x and x will give me s squared. Then we multiply the outside. The outside will be 3 is outside here, and also s is outside. The first binomial, s is outside. The second binomial, 3 is outside. So we multiply 3s. Then the inside will be the first term minus 4. The second term is x, so minus 4x. Then the last, of course, will be minus 4 and 3, so minus 12. It's kind of a method we call the FOIL, but it doesn't matter which one you multiply first. As far as we multiply all the terms, x and negative 4 with s plus 4, we will get the same answer. So when we combine the terms, our answer becomes s squared minus s minus 12, because plus 3x minus 4x will give me minus x. We have only one constant value, negative 12, so we keep it. Now, let's see the second example. The same thing, we'll multiply the first term first. So we get 3s and then 2x. That will give me 6s squared. Then we multiply the outside. Again, the outside will be 3s times 5, so it's 15x. Then we multiply the inside. The inside will be 2 and 2x, so that give me 4x. Then we'll multiply the outside, or the last 2 times 5 is 10. Then when we combine 15x and 4x, that will give us 19x. So we get 16x squared plus 19x plus 10. Now we also have additional special products. And some of us take, again, intermediate algebra. We know these rules. For example, the x plus a all square is called a perfect square, and always is in this form. Again, you can multiply x plus a by itself twice using the FOIL method. You get this answer. But this is something that after a while we get used to it. So if I'm solving algebra expression and I saw s plus a square, I can just write this term. So this will give me x squared plus 2ax plus a squared. Now s minus a all square, so give me s squared minus 2ax plus a squared. Then this is the e is called the difference of two squares. Now if I have 4 minus 9, I can change it to 2 squared minus 3 squared, and my answer will be 2 plus 3 times 2 minus 3, difference of two squared. So s plus a, s minus a is the same as s squared minus a squared. Then we also have the cubic binomial formula. So if I have s plus a cubic, is the same as s cubed plus 3ax squared plus 3s squared is x plus a cubed. We can see how, first of all, it's s plus a cubed. So remember, your first term will be s cubed. Your last term also will be a cubed, the two terms. Then you take the 3, then x will be 2, then a will be 1. Then the second, we still have 3. This time, a will be 2, the exponent, and x exponent will be 1. The same applies to difference also, s minus a cubed. The only thing we have cube at the first, and the last sign also is cube. But the terms are the same, s cubed minus 3as squared. So the next one will be 3a squared x, then minus 3. So this is a rules. Again, we covered this in the pre-algebra classes. Again, the first is called the perfect square, the cubic, and also difference of two squares. Now, all algebraic expression can represent a real numbers. So the technique used again to perform operations on polynomials and also to simplify polynomials also apply to other algebraic expressions. So let's see if we can use some of the formulas we saw. Now here they say we should perform the following. That's solving the problem. So first we have 3 cube root, 3 times square root of 3 plus 4x, square root of y minus 5, square root of 3 minus 11x, square root of y minus square root of y minus x, square root of y. So the first thing we were going to do is to see if we have any like terms. So you can see that the square root of 3, we have 3 like terms. So we combine all. Well, let's go back one more. Let's see that. You see, we have a square root of 3, square root of 3, square root of 3. So that's like our term. So we can combine those terms. Then square root of y, square root of y, we have square root of y also, we combine. Here we will remove this parenthesis here by changing the sign. So minus times positive with minus, then minus minus with plus here. So we combine all the like terms, and then our final answer will be minus 3, because 3 minus 5 minus 1 will give me minus 3. How do we get 3 minus 5 minus 1? Let's go back to the question. We can see, let's go back. Okay, so here we can see square root of 3 minus 5 is here, plus 3 is here. And here also is 1, minus 1, because minus square root of 3, when we remove the parenthesis minus. So that's why, again, we have 3 minus 5 minus 1. Same thing applies to the y. We have 4 minus 11 plus 1, then x square root of y. So we combine, and that will be our solution. Now, the second question, we can see that we have s to the power 3 by 2 times s to the power half minus s to the power negative half. So the best way to solve this problem is to multiply s to the power 3 by 2 with the two terms. So this will give us s to the power 3 by 2 times x half minus s to the power 3 by 2 times s to the power negative half. Now we know that 3 half plus half will give me 2. 4 over 2, so that will give me 2. Then 3 by 2 minus half, if I subtract 3 from 2, left 2 over 2 give me 1. So that's why we have 1 here. So we can leave the answer like this, or if we like, we can factorize it also. Now the next question, we have square. So remember, we use this is a perfect square. So we write the x half or square root. Now, square root is the same as exponent of half. So we square the first term, then we multiply 2 with the first and second term minus, then we square the third term, and that's what we have here. Using the special rules we saw. Let's go back just a few seconds. Yeah. So the question looks something like this. Then we use this. So that's what we are doing. As we can see, this is all square, negative. So it will be s to the power half all square minus 2 times s to the power half times s to the power 1/3. Then plus s to the power 1/3 square. And that's what we have here. Now we know half times 2 give me 1. So we have x, then half times 1/3 give us 5/6. Then 2 times 1/3 will give me 2/3. So that will be our final solution. Now let's look at the d. The d also the same thing, difference of 2 squares, plus and minus. So I can square root of x, and I can also square 2, and it will be minus the difference. So that's why it's good to know those special format, the perfect square, etc. If you know this, solving some problems will be more quicker. Because if I see the form, I know what I will write. If I see the right side, the solution, I can write the left. Or if I see the left side, I can write the right. So it's very important to know it. The good news is that it makes us to solve the problem very quick. Now, instead of taking my time to multiply each term, I saw a difference of 2 square, plus or minus, they are multiplied, and the 2 are binomial. So which means I should square root of s and square 2, that's it. And then the answer will be s minus 4. Now with division also, we can do a binomial. So let's see this example. Divide 4s cubed plus 4s squared plus 5 by 2s squared plus 1. Now, when we have a trinomial, the process is a little bit longer. So for example, we are dividing the 2. So I will take 2x squared and I will divide it by the terms here. So you can see 2s squared, you divide it by the first term, we get what? 4s cubed, and divided by 2s squared. My answer will be 2s. 2x multiplied by 2s squared will give me 4s cubed. So my answer is, now you are going to use the 2x to multiply the divisor here, multiply by 2s squared plus 1. And that gave me 4s cubed times 2x. So that's what we have here. Now, the reason why we put this underneath, because they have the same term. Remember, addition, subtraction, the polynomial have to be in the same term. Here we are doing subtraction. So when you get your result, you subtract it from the original top. So 4s cubed minus 4s cubed, they cancel. You bring the 4s squared down. 0x minus 2x will give me minus 2s. Then you bring there. Now, the next thing we're going to do, we take the 2x squared. We are going to divide it by 4x squared. And that gives us 2. Again, we are going to divide it by the last answer we have here. And that gives us 2. Then we multiply 2 by the terms again. So we get 4x squared plus 2. And that's what we have, 4x squared plus 2. Then we subtract again 4x squared plus 2 from 4x squared minus 2x plus 5. So 4x squared minus 4x squared will cancel. Minus 2x will bring it down. Then 5 minus 2 will give me minus 2x plus 3. Now, when we reach minus 2x plus 3, we can see that our divisor, the exponent is x squared. So we stop there. So this will be like a remainder. Since the 2x squared here, the exponent is 2, but our solution, the exponent is 1, we stop. Now, if it's 2, we can do it. So this means minus 2x plus 3 will be our remainder. So our answer will be, the final answer we get here, 2s plus 2. So 2s plus 2 plus, we're supposed to divide 2 minus 2s plus 3 by 2s squared plus 1. So it's like remainder that is left. So that will be our final solution. So that will be the conclusion for this lecture. So in this lectures again, we learn how to add, subtract, multiply, and divide polynomial functions. Again, thank you and see you in the next class.